Absolute value inequalities, the basics. Absolute value is the distance from zero. That means it's never negative or non-negative, okay? The absolute value is always positive. Everybody gets this part right here just fine, but that's actually a false statement if you leave the or zero part off. Because the absolute value is the distance from zero. How far is zero from itself? It's zero. I know that sounds funny. How far are you from yourself? You're nowhere from yourself, right? So the distance is zero. You're always where yourself is. I know that's crazy, all right? Absolute value less than or equal to. So here's less than. Less than or equal to is this one. Is an intersection. It's an and, okay? It's an intersection. It's an and. So then less than, let us make a sandwich. I know that's crazy. I'm an associative learner. I can associate, hey, less than, let us make a sandwich. Less than, let us make a sandwich. Okay? Absolute value greater than or equal to. So this is greater than. Greater than or equal to is this one. It is a union, which is an or. The math symbol for the union is this. It is down and up. It is not the letter U. It does not have the kickstand, all right, or the tail, all right. I like to ride bikes, so kickstand sounds good to me. But anyway, it's not the letter U. It's down and back up. Don't put the letter U. That's not a symbol union, all right. It is. I think about it as great or. I know it's greater. All you English people get mad. It's ER, not OR. I know, but great or. Right? So then, let us make a sandwich is less than, greater than is greater. Or sandwich. An and in math can always be written simpler. So what we're going to do is we're going to write a compound inequality when it's less than, and it makes sense. We got to make sure it makes sense when we start. So special cases, absolute value less than a negative has what? No solution. Think about it. Absolute value of something, we'll just put f of x for some function. Absolute value is less than 0. Look, this is positive or 0, less than 0. I'm sorry, not 0. Less than what? Less than a negative number, okay? So positive or 0 is never less than a negative, so that can't happen. That's why that says no solution. And then absolute value greater than a negative is always true. If I have the absolute value of some function, all right, or absolute value of anything, and I say greater than negative some number, when is a positive number greater than a negative? Always. When is 0 greater than a negative? Always. So it has a solution of all real numbers. Everything works. Take your favorite number, plug it in, it works. Take your neighbor's favorite number, plug it in, it works. Take your friend's favorite number and plug it in, it works. All right? It always works. So let's just start off with some simple ones. Absolute value of x, all right? And let's talk about this in the sense absolute value is less than 4. Wherever you are now, let's pretend like you're somewhere, your house, whatever, and let's say that you want to know all the people that live within 4 miles of you on your road. Well, you could go 4 miles one way and paint a stripe in the road, and 4 miles the other way and paint a stripe in the road. And if it says absolute value is less than 4, is that the people that live in between the two stripes or outside the stripes? Less than 4 means they live closer than those stripes. They're between those two stripes. So if you had your road that ran by your house, we know it's not straight, but pretend like it was. Here's your house, right? And then you went 4 miles this way and 4 miles this way, right? So less than 4 is everything in here. Absolute value less than is everything in the middle, okay? So here's how we do this. We say, okay, x is less than 4. That's the first part of this. But it's an and we're going to write it as a sandwich. We're going to sandwich this x, okay, between -4 and 4. So when you have absolute value, the only thing that never changes is what's in the absolute value. Everything else changes. Think about when we had equals. If you take an equal sign and turn it around, if I take an equal sign and flip it, guess what? It still equals. If I flip it this way right here, all right? If I flip it around, it's still going to be equals. So this one, you say, well, you didn't flip that one, Mr. Guest. Yes, I did. Look, if you take this by itself, this is not proper math here, so forgive me. What is the alligator eating right here? The alligator is eating the 4, right? He's got his mouth open, going to eat the 4. So let's go back here. What if we take this by itself? What is the alligator eating? Oh, wait, it's eating the X. So that actually is pointing in the other direction. We just put the number in front of the X this time so it looks different. Okay? But what's in the absolute value never changes, and we built a sandwich around it. Because it was less than a positive number, it made sense, and we went ahead and did this. If it had been less than a negative number, we'd say garbage. No solution. Okay? So here, how do I get X by itself? Well, guess what? It already is by itself. So what I want to do is I want to write it on my number line, draw it on a number line, and then write interval notation. Your teacher, depending on what level you are, okay? I teach this 3 different algebra class levels currently, okay, when I'm making this video. And in one of the classes, this solution, this is the inequality. This is the inequality, and that's where I want you to leave it. You get that far, you're good. Okay? You get that far, you're good. I'm probably going to practice the other stuff, but that's the inequality, okay? Inequality meaning these symbols right here. The less thans, the greater thans are inequalities, okay? So now I want to then come over here and on a number line, okay, this is going to be my number line. Wait. You know what? I'm going to do this. This is my inequality in red, okay? And then I'll do my number line in a different color here. So we're going to do my number line. And how many numbers do I care about? I care about 2 numbers. Which one's smaller? Negative. It doesn't matter what order they're in up here. Put the smaller one on the left and the larger one on the right. Okay? So my number line is going to be in blue here. Okay, my number line. So where do I shade? Where is the X? The X is between the 2 4, the 4 and the negative 4. I started with 2 4s, but one of them's negative, right? So between the positive and negative 4, so I'm going to shade in between the 2. I'm going to shade in between the 2. So that was my inequality. This is my number line. Now, back in the day, when you first learned number lines, you did something like open circles and closed circles, right? You either included it or you didn't include it. You put a closed circle or open circle. Well, remember, when we're doing interval notation, we take that open circle and we cut it in half. We take this open circle if it's no equals, and we cut it in half. We have parentheses. If we have the closed circle, that has the equals on it, right? It looks one of those two, and it's got the straight line, so it gets a straight line equals. That's how I associate it. I associate cutting this open circle in half. That's how I associate it, okay? If you need more help with that, watch my video on interval notation and how to write those things, all right? So, but here, we don't have equals. There's no equals here, so this is open circles or parentheses is what it would be on interval notation. So I'm going to put my parentheses on this. So then now that's the number line, and then finally, interval notation is going to be, let's see, let me go ahead and put this in brown. We have negative 4, comma 4, and we have parentheses. We have parentheses. Negative 4, comma 4 with parentheses. And that's the interval notation. This is what I'm going to box. This is the big dog answer, okay? And in 2 of the 3 classes, I require this on all the problems, okay? In one of the classes, the beginning level that we teach, where I am at currently, we do this. We just say, okay, give me the inequality, so that's where we stop on some problems. We still go and do the interval notation. We just do it separately to kind of drive home the point of each one. All right. So we have an inequality, we have a number line, we have interval notation. There's 3 different levels. In my classes, the way I grade mine, if this were a 5-point question, this would be like 2 points, this would be a point, and this would be 2 more points. That'd be my 5 points. Okay. That's what I would do. All right. I would give you points for each step along the way because each one of them matters. You can't get the next one right without getting the first one right. So then makes it harder to grade, but that's how I do it. All right. Absolute value of X is greater than or equal to 8. Absolute value of X is greater than or equal to 8. This is greater, and I should have written that down up here. Let me write this on the first one. This was less than. This was less than, so it was let us, let's not make a sandwich. All right, here's my sandwich right here. Okay, so then the next one is greater than. That says greater than. I know that's terrible. Or equal to. I got to fix that. That's awful. All right, this is Let me write this a little slower. Greater than, I still can't write, or equal to. Okay? Greater than or equal to. So then, greater than I think of as great or. So I'm going to have an or. The first part is going to be drop the absolute value. X is greater than or equal to 8. Just drop the absolute value. Just write it down. And what never changes? The X, right? Or X. And then everything else changes. The alligator over here, the alligator's eating the what? The X. So over here, I want the alligator to eat what? The number. And I changed the number. This was positive. This is negative. And the reason that changes, we talked about dividing the negative 1 on my absolute value equations equals. We divide that negative 1 over. That's the proper definition in the book. And that's where a lot of you get the pluses and minuses mixed up on some things. But here, I really had this. And when I divide it by negative 1, right, this flips around to that, and that becomes negative 8. Okay? So that's what's going on there, because that negative is in front of the X, and I divide it to the other side. But I'm changing everything except what I'm not changing, which is in the absolute value. I never change what's in the absolute value, and I change everything else. Okay? So here, this is actually already solved. This is my what? What do we call this? That's my inequality, right? That is my inequality. Then I move from my inequality and I do what? A number line. This time, how many numbers do I care about? Still 2 of them. Which one is smaller? Do I put 8 in negative 8 because that's the order they're in over here? No. This one is negative 8 and this one is 8, right? Smaller number on the left, bigger number on the right. Number line, right? Smaller numbers are on the left of the number line. Bigger numbers on the right of the number line. So my number line, that's this one, okay? So then X is greater than or equal to 8. Which way is that? If I start at 8, which way is greater than? Aha. That's out here to the right. And when I get to an arrow on a number line, remember I shade that arrow. And then I write down what that arrow represents. You don't have to do that, but it lessens your chance for careless mistakes. I'm going to shade that arrow, and that arrow is infinity, right? And then what goes around the 8? Well, look, do I have the equals here? Yes. And remember, the equals gets the straight line bracket, so I go bracket. Straight lines, brackets, boom. All right, so bracket 8, go out to infinity. X is less than or equal to negative 8. Which way is less than negative 8? To the left. So I'm going to shade out here. Again, I get to the arrow, and I'm going to shade the arrow. And then what does that arrow represent? Negative infinity. Infinity and negative infinity are just a direction. They're not a number, they're a direction. Okay? And then what goes around it, again, it's equal, so I get a bracket. Bracket, all right? So how do I write my interval notation? Well, my interval notation is going to start where I have it shaded. I'm shaded all the way right. This one started at negative 4. That's why I put that first. But this one starts way out here at negative infinity because that arrow is shaded. So I go negative infinity, parenthesis. The reason is infinity, I just told you, was a direction, not a number. So if it's not a number, there's no way to include it. There's no way to include it. Infinity and negative infinity always get a parenthesis. On this problem, though, the numbers, when I go negative infinity up to what? If I keep working this way, where do I stop shading? Right here. What number is that? Comma, negative 8. And then on that negative 8, I have a bracket, right? I have the bracket. Just bring that down, whatever it is, okay? And that's because it's on a number that you can include. Or, I don't write the word or. I told you what the symbol was, what was a union, and that was down and up. Don't do this. That's got a tail or a kickstand, and that's not right, okay? So don't do that, okay? Just down and back up. Union. And then as I keep moving across, where do I get to here, which is what number? 8. And what goes around the 8? Bracket, right? Bracket. Bring that bracket down. And then comma, and I go all the way out to what? Infinity. And what do we say infinity and negative infinity always get? A parenthesis. So there is my interval notation right here, okay? That's my interval notation. So I got all these extra arrows all over the place here, but I'm just saying that's how those things link up. So absolute value less than is let us make a sandwich. You have one interval. Absolute value greater than, you have two intervals. And again, it made sense. Absolute value greater than a positive number is going to have two different ones there, okay? So we didn't have the special case in these. So absolute value of x is greater than 1. Absolute value of x is greater than 1. How do I do this? Well, this is greater than, so it's great or. What is my or? X is greater than 1 or x is what? Less than negative 1. We change the inequality sign, the direction, and the number from positive to negative. We change both those things. Because remember, what we're technically doing is dividing that negative 1 across. And when we divide by a negative in an inequality, we have to change the direction of that inequality. This is already solved. This is my inequality. Now let's draw the number line. What does my number line look like? Well, I have two numbers I care about. Which one's smaller? Negative 1 has to go on the left, 1 on the right. X is greater than 1. That's out here, and that's going this way. Shade, shade, shade the arrow. If I shade the arrow, what does that give me? Infinity, or what does it represent? And then 1 gets a parenthesis because there's no equals right there, right? If it had been this, it would have gotten a bracket, or a bracket this way, I guess. Okay? And then x is less than negative 1. Which way is less than? Back here to the left, and then that, like this, and then this is what? Negative infinity, and then we have a what? Parenthesis. So that's the number line. And then we go from the number line to the what? Interval notation. Where did I start shading? Negative infinity, comma what? Negative 1. And here, both of them get what? Both of them get parentheses. And then union, right? That's the or union, or what? Parenthesis 1, comma, infinity with a parenthesis around both of those as well. Okay? Parenthesis around both of those as well. So the next one, absolute value of x is less than or equal to 6/7. So then if I do that, this is going to be what? Let us make a sandwich. Okay? Let us make a sandwich. So then, what is my sandwich like? Well, look, absolute value is less than a positive, so that's good. We can keep going. It's got to be that way. All right? So then, x is going to be less than or equal to, and then over here it's going to be greater than or equal to. Even though they both point the same direction, x is bigger than whatever comes before it. Remember, we do that negative on the left and the positive on the right. We leave this pointed the same direction in all three places. So, now how do I solve this? How do I solve this? Well, guess what? X is already by itself. X is already by itself. So I don't need to solve anything. That's my inequality answer right there. So then I need to go from my inequality to my number line. What numbers do I care about on my number line? I care about two of them. Which one's smaller? Negatives. And look, it's okay to have a fraction marked on your number line. Okay. You don't have to have negative 1 and 1 marked because that's close to negative 6/7 to kind of guess where it's at. No, just mark the fraction. You also don't have to mark 0 in the middle, okay? Because there is no middle. The line goes on forever. There's a middle to what you drew, but still, all right? And you don't have to do 0, 1, 2, 3, 4 to get up to 27. Just put 27 on the number line. So here, where is x? X is in the middle. If x is in the middle, then guess what? I'm going to shade in the middle. So if I shade in the middle, did I get to either arrow? No. So do I shade either arrow? No. So do I have any infinities here? Nope. Do I put brackets or parentheses? Well, guess what? They both have equals, so guess what? They both get brackets. So bracket, bracket. And we always open our bracket or parentheses up towards the shading, okay? That's the number line, and then finally the interval notation goes bracket, what number? Negative 6/7, comma, 6/7 with a bracket. All right, and so let me say this for my students. Never do this. Bracket, oh, it's supposed to be a parenthesis. If you write both of those things down, I'm counting it off, okay? So I don't care if you say, well, it's darker. What do you mean it's darker? You're using the same pen or pencil. Okay, you better be using a pencil on a test, by the way, in math. So you can't do that. You can't write both signs there. So erase it and fix it, okay? Don't try to write both and write one darker than the other or anything like that. All right? Absolute value x plus 3 is less than or equal to 5. So here's less than. What are we going to do? This is let us make a sandwich. And it's less than a positive, so we're good there. We can keep going. If it's less than a negative, it's a special case. Less than 5 would keep going. So then look, we don't ever change the x plus 3 part. We put less than or equal to 5, and over here greater than or equal to, even though it's the same way, right? The alligator's eating the x plus 3, negative 5. So negative 5 is less than or equal to x plus 3 is less than or equal to 5. So it makes sense. It goes in order. A negative is smaller than something that's smaller than a positive. That makes sense. Right? So then this thing is ready to be solved. And by the way, if it makes sense here, it better make sense in the next step. Logically makes sense. And then how do I solve this? Well, I'm going to subtract 3 from all 3 places. That cancels, and I get what? Negative 8 is less than or equal to x is less than or equal to 2. And that is my inequality solution. Okay, if I say solve the inequality, that's it. That's the answer to solving it. Now again, many teachers I know, right, require interval notation as the big dog answer. Okay, so you make sure you check with your teacher what they want, no matter what their directions say, because they're the teacher. Okay, in my class, if I just say solve the inequality, that's what I want you to give me right there. But I'm going to say solve the inequality, graph it on the number line, and write an answer in interval notation. I'm going to tell you all 3 things to do, because that's what I want you to do. All right. Here I'm just introducing it and talking about the different parts and pieces, okay? So then on my number line, I care about 2 numbers. Which one's smaller? Negative 8. Which one's bigger? 2. Where do I shade? In the middle. And then a bracket and a bracket. And then how do I write my interval notation? I say bracket, negative 8, comma 2, bracket. So I have the inequality in red, the number line in blue, interval notation in brown. Okay? 2x minus 3 is less than 7. What do we do with less than? Less than, we make a what? That's not a C. Let us make a sandwich. Let me flip back and check something real quick on this next screen, last screen. All right, so absolute value 2x minus 3 is less than 7. So again, it's a sandwich. We're going to say 2x minus 3, and we're going to sandwich it between the, those are going to point the same way, but remember the alligator's eating the 2x minus 3 one time and the number the other. Put the positive on the right and the negative on the left. And there's my sandwich. But I haven't solved the inequality yet, right? Let me fix this. 7 looks gigantic. Okay, so we haven't solved it just yet. We've just written it down. So now we're going to solve it, and we're going to add 3 to all 3 places or pieces, okay? It's not just both sides here. It's both sides in the middle. That cancels, and we get negative 4 less than 2x less than what? 10. Then we divide both sides by 2, and the middle, all 3 places or pieces again, right? Everything's got to get divided by 2. Negative 2 less than x less than 5. That's my inequality. I solved the inequality. Now let's graph it on what? A number line. And I realize some of y'all can skip the number line, and that's fine, okay? That's fine. But if I say it in my directions, I want them all there. But at some point when you get far enough along in algebra, I start letting you skip the number line if you want to. But I just think it helps. I'm a visual person to see it, and I like to see it, so I think it helps. And if you're visual, this really helps. So which one's smaller? Negative 2. Which one's bigger? 5. Where do I shade? X is in the middle, so shade in the middle. So then parenthesis. Why do I use parentheses? Because there's no equals on this, right? There's no equals on those. And then how do I write my final answer here? Negative 2 comma 5 with parentheses. Negative 2 comma 5 with parentheses. So then absolute value 3x minus 4 is greater than 5. It's greater than a positive, so it's okay. This is going to be great, or. What's my or? All right, so remember before my or, I just dropped the absolute value, and there's no 2x up there. All right, this should be what? 3x. I can't even copy my own problem, right? 3x minus 4 is greater than 5, or we never change what's in the absolute value, 3x minus 4, less than negative 5. We change the inequality direction and the number because we're dividing the negative on both sides. That's why we change that from greater than to less than. Now I need to solve the inequalities. Okay, this time I have 2 to solve, so I'm going to solve each one of them individually. Add 4, 3x is greater than 9, divide by 3. So x is greater than 3. I'm not through solving. Go to the next one, plus 4. That cancels. 3x is less than negative 1, divide by 3. And those divide out. X is less than negative 1/3. My answer is negative, but I did not divide by a negative here, so I don't change that less than. And down here we bring down our or. That's the inequality. That's the solution of the inequality. Now we're going to graph it on a number line. So then on my number line, I have how many numbers that I care about? 2. Which one's smaller? Be careful. Negative 1/3 smaller than 3. And not because it's a fraction, it's because it's negative. The other one's positive. X is greater than 3. Let's deal with this one first. Which way is greater than 3? That's going to be to the right. So we're going to start at 3 and go to the right. And then we're going to shade the arrow because we went all the way out to the end. And if I shade the arrow, what does that represent? Infinity. And then what's that going to be? Oh, not going to be a bracket. What's it going to be? Parentheses, right? Because it's no equals on it. And then or, let's look at this one, less than negative 1/3. Which way is less than? To the left. And that, there's your arrow, negative infinity. And we have a parenthesis, right? So, negative, let's see. That's my number line. I'm going to change my color here. That's my number line. And then how do I draw or write my interval notation? Well, it's what I have shaded. Negative infinity, comma, negative 1/3. Negative infinity has what? Parenthesis. Negative 1/3 has what? A parenthesis. This brought down here. And then what's the word for or? The symbol for the word or. Union, right? And then parentheses, 3, comma, infinity. And what does infinity always get? Parenthesis. Those parentheses are not related to these. This has nothing to do with that, okay? Has nothing to do with that. This is this one. Infinity and negative infinity always get a parenthesis no matter what. Absolute 5x minus 3 is greater than or equal to 27. So we're going to say 5x minus 3 greater than or equal to 27. Or, right, this is great or. Great or. Or what? 5x minus 3 is less than or equal to negative 27. And then we do what? We solve each one of these inequalities. We say, okay, add 3 to both sides. 5x greater than or equal to 30, divide by 5. Oops, that's a pretty bad 5, so let me fix it. That divides out x is greater than or equal to 6. We didn't divide both sides by negatives, so leave it. Or what do we get over here? Well, let's solve it. Plus 3 on both sides. We're moving the minus 3. 5x is less than or equal to negative 24. Divide both sides by what? 5. And x is less than or equal to negative 24 over 5. And then we have a number line. And on my number line, what do I care about? I care about 2 numbers, right? Which one's smaller? Negative 24 over 5. I wrote all that stuff way too big, so I'm having to come down here. And then 6, the way I've been writing it out to the side. So greater than or equal to 6. Which way is that? Well, that's going to be, right, it's going to be to the right. I get out here to this arrow and shade this arrow, and that arrow represents infinity. And this is going to be what? A bracket because of the equals, okay? And then less than negative 24/5 is to the left. That's out here. Right? Shade that. Shade that. That's going to be negative infinity. This is also going to be a bracket. And then you have negative infinity. This is interval notation. Negative infinity, comma what? Negative 24/5. Negative infinity always gets a parenthesis, but this time negative 24/5 gets a bracket because it's equals. What's the symbol for the word or? Union. Then we have a bracket, 6, comma what? Infinity with a parenthesis. All right, so there's your interval notation there. The negative infinity with a parenthesis, comma, negative 24 with a bracket, 24 fifths with a bracket. Unions, bracket 6, comma, infinity, parenthesis. Here, absolute value of 11x plus 1 is less than or equal to a negative. When we say, oh, wait a minute, absolute value is by itself less than a negative. That's a special case. Well, this was positive or 0, less than or equal to a negative. Ain't never going to happen. No solution. No solution. No solution. So x minus 9 greater than negative 5. All right, so here greater than, but it's still a negative. That tells me, wait a minute, I need to have a little pause here. I've got the absolute value compared to a negative. Positive or 0 greater than a negative. When is that true? This is always true. Always true. So that means what? Everything works. There's your interval notation. You can say all real numbers, okay? And so back when I was in school, we would do this, all real numbers. And all y'all are going, why is that all real hashtags? Because that was number. There was no hashtag whenever I was in school. That was a long time ago. All real numbers. You could write it out. I would accept either one of those. And there's a symbol for all real numbers. It's the letter R with an extra line in it. There's an extra line. So that. And that is often equivalent to the interval notation. There are many books and teachers and professors and things that will accept this for interval notation, and I'm one of them. All right? So I'll take any one of those three. Technically, if it says interval notation, technically I should make you do this, and this is okay because some books do that. But I wanted to show you all three ways to write that there. All real numbers. Everything works there. Every real number you can think of works there. This is that whole your favorite number, friend's favorite number, whatever. So here, absolute value of 3x minus 4 plus 5 greater than 13. So here's the deal with this, okay? You need to be sure that the absolute value is what? By itself. If the absolute value is not by itself, it's no good. So I've got to take this and move it over. How do I do that? I've got to subtract 5. So 3x minus 4, still an absolute value, haven't dealt with that yet, is greater than what? 8. 13 minus 5 is 8. Now I have a greater, right? Now I have a situation where I have great or. Okay? So, and it's greater than a positive number, so that means I keep going. I have the or. And on one side, 3x minus 4 is greater than 8. Don't change it. And over here, do I change 3x minus 4? No. I changed the greater than to what? Less than, and the 8 to negative 8. So then I solve each one of them. 3x is greater than 12. Divide by 3. X is greater than 4. And then here, I'm going to add 4. 3x is less than negative 4. So x is less than negative 4/3. So solved each one of those individually. We got the or between them. And then on my number line, I care about how many numbers. That's right, 2 numbers. Which one's smaller? Negative 4/3, and which one is larger? I don't know why I wrote a 3 down, because 3 is not up there. It's 4. Right, that's this number here. So then x is greater than 4. X is greater than 4. Let's just start at 4 and go out here to the right and shade the arrow. That's infinity. And then what about the 4? You get a parenthesis because there's no equals. Less than negative 4/3 is to the left. Shade the arrow because you get all the way out there to the end. And that's negative infinity. And then you have a parenthesis here, right, because there's no equals. So you have negative infinity, comma, negative 4/3, and everything here gets parentheses. Right, infinity and negative infinity always get parentheses, and then this parenthesis goes here. Union, right, down and back up, parenthesis 4, comma what? Infinity with a parenthesis. So there's your interval notation, and I just realized I did that in the same color, and it's going to bother me, so I'm going to change it. because I've been doing inequality one color, number line another color, and my interval notation. So I had the interval notation correct. I'm just going to change it to gray here. So parentheses around these, I said union, then we had forward to infinity with parentheses, right? So 6x minus 5 in absolute value plus 15 is less than or equal to 2. So the first thing I have to do is subtract 15 from both sides. Now my board's going to act up, so do this. All right, it took this away when it canceled. All right, so 6x minus 5 in absolute value is less than or equal to negative 13. And then I go, well, wait a minute. I got a negative here. Wait a minute. I got a positive or 0 less than or equal to a negative. And when does that happen? Never. And one thing that some of the books I've taught out of, and maybe even one of the ones I use now does, is no solution. And in this case, because we usually are talking about a set of numbers, interval notation, lots of numbers, they'll use this empty set. Empty set. So just be aware that no solution, your book or your teacher or the online software, if you're using that for your class, may require you to put the empty set. Okay, all right, so that's going to be specific to your particular class. Okay, whether you're in mine or somebody else's, that's going to be specific to that class. If you're writing something down on a piece of paper, for me, no solution is fine. If you're working in my math lab or Hawks or whatever the platform may be, then it may require you to put the empty set. Okay. So just know that. Just know that. So then this one, let me go ahead and erase what I had to write or what I had to fix here to fix it. 2 times x minus 5 in parentheses plus 3, all in absolute value, plus 14 less than or equal to 21. All right, you got a couple of different ways to work this, but I'm going to work this the same way every time. And when you start seeing, hey, I can skip this step or do this different, or I can go ahead and do this before I do that, that's fine. I'm going to get the absolute value by itself and then determine if it's good and then write it down as a sandwich or an or, and then I'm going to solve each one of those individually, which may require, since there's work to be done in here, is going to require doing the same work twice. But again, that's what I'm going to do. So here, 2x minus 5 in parentheses plus 3, I'm going to subtract the 14 from both sides, right? So that cancels and I get less than or equal to 7. Now I have absolute value less than or equal to a positive number. So that's going to then give me this. This is sandwich. Okay? Sandwich. So 2x minus 5 plus 3 less than or equal to 7, greater than or equal to negative 7. In this case, because I wrote it as a sandwich and I didn't write an or, I didn't write it down twice, I'm only going to do the work once. But if it was an or, I'd have that 2 times x minus 5 business all, two different ones. Then I'd have to do it twice. But here, just have to do it once, thankfully. So to solve this inequality equation, distribute the 2, negative 7 less than or equal to 2x minus 10 plus 3 less than or equal to 7, and then put these together. So negative 7 less than or equal to 2x minus 7 less than or equal to 7. So all I did was just do the algebra inside here, right? To work it and simplify it. Now I'm ready to do some different kind of algebra. I simplified there. I'm ready to do some different kind of algebra here to get the x by itself. So what do I need to do? Add 7. And whatever I do in one place, I have to do what? In all 3 places, both sides and the middle. That cancels and we get what? That actually cancels and gets 0, doesn't it? Less than or equal to 2x, less than or equal to 7 plus 7 is 14. And then we divide everything, all 3 places or pieces, by what? 2. 0 over 2 is 0, less than or equal to, that divides out, x. Then we get less than or equal to 14 divided by 2 is 7. 0 less than or equal to x, less than or equal to 7. That is my inequality. Then I go to my number line. And on my number line, I care about how many numbers. 2 of them. Which one's smaller? 0. Where do I shade? In the middle. Do I have any infinities involved here? Nope. What goes around 0? Bracket. What about 7? Let me fix it. That's a bad one. Bracket. And so then we have, for my interval notation, I have what? Bracket, 0, 7 with a bracket. Bracket, 0, 7 with a bracket. All right? And then here I just gave you another fraction to deal with here, right? But again, absolute value is compared to a number. It's greater than or equal to a 1. So I'm not going to deal with the fraction. I'm going to look at this and go, okay, this is great or, okay? And I'm just going to go and have fun here. I'm going to use all my colors on this problem, all right? So I'll call it the Skittles Taste the Rainbow problem for the video, all right? Taste the rainbow, right? So then 3x minus 4 over 2 is greater than or equal to 1. And we said this was going to be an or. Or, what's the other part of this one? We don't change what's in the absolute value. 3x minus 4 over 2 is less than or equal to negative 1. That's what we change. That's what we change. So now I'm going to solve the equation on the left. What's my LCD? It's 2. I'm going to multiply 2 times all of it on this side and 2 times all of it on this side. Okay? And I'm going to remind myself that this 2 is really over 1. Divide those out. I get 3x minus 4 is greater than or equal to 2. And then how do I solve this? I'm going to add 4 to both sides. Let me fix that 4. I don't like it. That cancels. I get 3x is greater than or equal to 6. And then divide both sides by what? 3. So then x is greater than or equal to 2. And I still have my or. How many ever steps this takes when I get down here, I still have that or, right? So, let's see, I'm going to do the same thing. What's my LCD right here? 2. So I'm going to say 2 times 3x minus 4 over 2 less than or equal to, I've got to close that, 2 times negative 1. And then I'm going to say, okay, wait a minute. This is going to be over 1. That divides out, and I get 3x minus 4 is less than or equal to negative 2. And then I say, okay, let me add 4 to both sides. 3x less than or equal to 2. Let me fix that. That was awful. And then finally, what do? Divide both sides by 3, right? So then x is less than or equal to 2/3. So x is greater than or equal to 2, or x is less than or equal to 2/3. So then I'm going to come over here and I'm going to have my number line. And I care about 2 numbers. Which numbers do I care about? Well, I care about 2, which was larger, and I care about 2/3, which was smaller than that. Right? And when I care about 2 here, when I care about 2 right here, which way do I shade? Greater than 2 is going to be out here to the right. Shade out here to the right, and that's going to be infinity. And what goes around that? Bracket, because it's got the equals. And then here on the next one, oh, wait a minute, I'm not changing color yet. Which way is less than 2/3? It's to the left. So come out here and shade this arrow. What does that arrow represent? Negative infinity. And what goes around the 2/3? A bracket. And then we get negative infinity, comma, 2/3, and then 2, comma, infinity. And we have parenthesis around infinity and negative infinity. We have brackets around the other numbers. And then what goes in the middle? The union sign. And there's our interval notation, right? That's our interval notation. So I had a little fun with the colors there. I used all the colors that I use when I use this board. All right. So hope this helps with absolute values of inequalities.